Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. On this occasion, we will present a topic on geophysical instruments, specifically instruments used in earthquake observations. The main focus of our discussions today is two vital tools in MKG instrumentation, namely the Streckeisen STS 2.5 seismometer and the Quanterra Q330HR digitizer. To facilitate understanding, we have divided this presentation into 5 main sections. First, we will begin with an introduction to the tools. Second, we will discuss the quick few-wheeler feature. Third, we will provide technical guidance on installing the STS 2.5. Fourth, we will discuss the data processing process. And finally, we will conclude with guidance on installing the Q330HR. Let's move on the first device, the Streckeisen STS 2.5. This device is a high-performance, portable, very broadband triaxial seismometer. In the world of seismology, the STS 2.5 is recognized as the world standard, against which other seismometers are often compared. Its advantages include very low noise levels, high clipping levels, low power consumptions, and the ability to operate over a wide temperature range without the need for readjustment. When it comes to technical specifications, the most crucial aspect of the STS 2.5 is its frequency response. The response graph of this device is fed to ground velocity, meaning it has stable and flat sensitivity to ground velocity. From period of 120 seconds or 8.33 MHz to a high frequency of 50 Hz. This allows the device to record both distance, teleseismic, and local earthquake with high accuracy. Next is the clip level or the maximum signal limit that can be recorded before clipping. The STS 2.5 can handle ground vibrations up to 13 millimeters per second at frequencies up to 20 Hz. For frequencies above 20 Hz to 50 Hz, this limit undergoes linear delating or a linear decrease to 5.3 millimeters per second. These specifications ensure that the instrument continues to record complete data even when there are strong ground vibrations. Finally, for the STS 2.5 specifications, we look at the signal output and its physical characteristic. This device has a maximum seismic signal output of 20 volts differential with a serial resistance of 220 ohms per channel. Its generator constant is 1500 volts seconds per meter. Physically, the sensor is quite sturdy with a total weight of 12 kilograms, which helps with its stability when installed in the field.
The next topic is how to install STS 2.5. The first step is in the state preparation and sensor step. First, choose a stable inner substructure like bedrock or slow hardening concrete with a flat, clean, dust and sand-free surface. Second, ensure the stability by provide thermal insulation and protect against temperature variation and air convection, which can degrade data quality. Third, loosen the counter nuts on the 3 feet by turning them a quarter turn counterclockwise and screw the feet as short as possible. Fourth step is insert the orientation rod into the hole on the base ring to assist with placement, then remove it. The next step is the physical placement and leveling. First, place the sensor gently on the prepared spot. Then insert the orientation rod again and orient the sensor to the rod points toward E6. Remove the rods. Third, remove the protection cap from both the sensor and the cable connector. Plug the sensor cable into the sensor connector with firm pressure until an audible click indicates a complete watertight connection. Fourth, lay out the cable so that it does not transmit mechanical motion into the sensor case. Fifth, use the feet to level the sensor while watching the internal bubble level. The bubble must be in the center of the inner ring when viewed just below the rim of the cover. Sixth, tighten all 3 feet by turning their counterclockwise until they lock firmly. Last step is initial operation via hostbox. First, connect power to the hostbox because the hostbox is initially asleep and all LED are off. Then press either the center or lock or unlock button to wake the hostbox and display the sensor status. If the sensor is locked, press the lock unlock button, then red light will turn off. Press the center button to initiate the fully automatic centering process. The centering process can take up to several minutes, and if successful, the status light will turn green. After approximately 60 seconds of inactivity, the hostbox will return to sleep mode and all lights will extinguish. This indicates the system is running regularly.
The next part is how to install Quanterra Q330HR. The first one is preparation and safety. First, unpack and inspect the unit. Check the shipping carton for damage. Carefully unpack the unit from its custom design box. Ensure the unit has no signs of external damage. Second one is safety and grounding. You must provide a good low impedance earth ground for the Q330HR before operation. Proper grounding is critical for maintaining the recorder as a sensitive, low noise seismic recorder, as well for shunting ESD, lightning, and EMI RFI transients to the earth. The third one is operating environment. The unit should be installed in a location consistent with environmental requirements, including the specified operating temperature range and away from direct sunlight. Initial setup with PC. Position the unit. Place the Q330 so the QNet cable can reach the power unit and hub. GPS antenna connection. Connect the GPS antenna to the Q330. Position the GPS antenna outdoors or near a window. Network connection QNet. Connect the QNet cable to the QNet port of the Q330 and connect it to an available connector on the TEE adapter. Serial console connection. Connect a serial cable from your PC's COM port to the Q330's console port. The power connection. Connect the 6-pin external power connector to the Q330HR EXT power connector and twist until it locks. Connect the power cable to the TEE adapter. Connect the power cable to a high-quality, regulated 12-volt DC power source. The voltage should be regulated between 13.5 to 14.5 volts. If using the optional power supply assembly, plug the PSA into a properly earth-grounded AC outlet. The last one is software preparation and configuration. To configure the unit, you will need to prepare a Windows PC with Quanterra support tools such as Willard, Picos, and Cimarron. Prepare the PC, create a directory for the Q330HR support tools, disable conflicting programs, disable any third-party firewalls such as McAfee, Symantec, Anti-Spyware Antivirus, and conservative energy settings that might shut down the hard disk on screen. Disconnect LAN initially. For initial work, disconnect your LAN connection from any other LAN that might have Q330's running older firmware to prevent confusion during setup. Configure the Willard. Use the Willard program to view stages and issue commands. Register with the Q330 over the console port. Set and change the Q330's Ethernet IP address. Load and save the Q330 configuration as an XML file.
And now, I want to explain about how to access Quick View Wheelers. First, you should ensure that the Q330HR data logger is connected and powered. and that the STS 2.5 sensor is unlocked and ideally centered. Basic SOA checks or power and GPS should already be confirmed. And when you access the Willard, open the Willard app and ensure that the connection to the destination station has been successfully established. And in the menu navigation on the Willard Graphical User Interface or GUI, navigate to the status menu. And the execution is select the quick view command. And then storm testing and signal chain verification. Once the quick view window is open, the next step is functional testing to confirm that the mechanical signal have been successfully translated into valid digital data. And action, the operator must deliver a sharp, brief mechanical impulse near the fault or STS 2.5 sensor location. And the verification is the quick view window will display status confirmation for the three component channels. Channels 1, 2, and 3 as north and vertical. The typical verification format aspect is the aux status on all three channels proves that the entire analog and digital signal chain is functioning. The impulse is captured by the STS 2.5, converted electrically, digitized by the Q330HR, and successfully communicated back to the Willard interface. If any channel fails to respond out, the failure is localized to the analog signal page, leading to inspection of the sensor cable or digitizer input. C. Connection, persistence, and network implication. Quick view function as a direct diagnostic tool. However, this feature has important implications for the overall network connectivity of the Q330HR. By default, Willard will automatically disconnect after a period of inactivity. However, when the quick view window is left open, Willard will remain connected indefinitely since the Q330HR is a network-oriented system that supports telemetry to up to 3 central IP addresses simultaneously. Maintaining this quick view connection key may inadvertently block other remote connection. Block connection may include secure shell or SSH session or status request from the central data facility. Therefore, standard operating procedure require that the quick view window be closed immediately after the operator has finished verifying the storm test and sensor match position. To ensure full availability of the Q330HR administration and telemetry ports for remote network administrators.
Now we will talk about data processing STS 2.5. There are many ways to process data from STS 2.5. However, we'll talk about the one that we're most familiar with. We will use PECOS 2 and Cimarron to take the data from the STS 2.5. This is how we take the data with PECOS 2. First, run PECOS 2 as administrator and click yes. Click on Station Manager to create a new station. In the ID box, enter the tag or ID number of your station with underscore and number 1 to indicate DP1. In the Q330 configuration for a station panel, select the Ethernet interface and if necessary, enter the IP address and serial number of your Q330 station and then click OK. Next, click on Add Station option. Then from the drop-down arrow, select your station ID and click on Add. In PECOS2 station panel, make sure to select the Ethernet interface, put 0 in the authorization code box, and check the box next to Save Authorization code. Click on Start, then the MSID data will be downloaded to the newly added folder. Now, view and pro the data with Cimarron. First, run it as administrator, then click yes on the pop-up message. If necessary, add a path to the directory box and click on create. For files, ASL, datasets, fork, and station will be added to the same path that you choose. From the Cimarron Downloads panel, click on File menu and then click on Index Message File option. Then click on Search Path option, check the root box and click on Add Path. Select the path where you downloaded your MSIG data and click OK. Then check the box next to the MSIG files that you want to view and process. Click on Index Selected option and you'll see a message indicating indexing complete in the Cimarron panel. Click on the New Plug option and from the Select Starting Day panel, click on the Hours option. For the closing, this is our group. There is Aqil, Amany, Ulil, Hafiz, and Faiq. I think that's all from our presentation and thank you for your attention.